Welcome back to another physics video. Today we are going to continue on electricity, and the topic we're going to talk about is the concept of resistivity. Okay, so what does it mean? It means that resistance is directly proportional to length and inversely proportional to the cross-sectional area. Okay, quite a long definition, but after this illustration, things will become clear. So for example, let's say if you have like one of our boys to men soldiers, running on a track and field thing, all right? And then he's going through two obstacle courses, course A and course B, okay? All right, so the difference between course A and B is that A is longer, all right? He has 4 things he has to jump across compared to course B, okay? So which route will be easier for our Mr. Soldier to run through? It is obvious, isn't it? It is course B, okay? So we say that A has higher resistance because it's longer, all right? Okay, so you apply this common sense to the movement of electrons in wire, it is the same. The longer the wire, the more distance it has to travel, then of course higher resistance, okay? All right. Secondly, the second type of obstacle course is like the pipe, they have to like crawl through the sewage, okay? All right. So, of course, other than the smell, then it's about the tightness of the space. So let's say if our Mr. Soldier, okay, all right, okay, I'm having a hard time drawing a crawling man, okay, all right, has to go through 2 pipes, and pipe C has a bigger area, all right, maybe it's like a 3 meter square compared to this only have 2 meter square. Both have the same length. Which will be easier for Mr. Orange Man to go through? C or D? All right, you're right. C is easier to go through because it's broader. All right, D maybe halfway. If it's a bit too overweight, he might be stuck. Okay, so we say that D has higher resistance. Okay, because of a smaller area. Okay, which lead to a smaller space. Okay. So these are the 2 main concepts about resistivity. So to express it in a mathematical expression, R is proportional to L over A, okay? The longer the length, the higher the resistance. The bigger the area, the lower the resistance. And we all know that if there is a proportional sign, we can turn it into a equal sign by introducing a constant. And this constant here, which is this rho, this P looking like thing, is what we call resistivity, all right? Resistivity, okay? All right? Different materials have different resistivities, and that is a constant for each material. They won't happy one day change their resistivity, okay? All right? So for example, gold has a resistivity of 2.44 times 10 to the power minus 8 ohm meters, whereas copper, okay, has a resistivity of 1.72 times 10 to the power minus 8 ohm per meters. Okay, so what this shows us is that for the same length of wire, copper actually has a lower resistance compared to gold, all right? So all these are considerations for engineers to think about when they build components. Do I need higher resistance? Do I need lower resistance? Okay, all right. How do we apply this to some of the standard questions that you're seeing in the exams? Let me give you a few examples. So first, let's say if we have wire A and wire, sorry, this is too long, yeah. All right, wire B, okay. All right, okay. So both are of the same thickness. So let's say if wire, I don't like orange, wire A is 5 meters, okay, and it has a resistance of 10 ohms. Wire B is 2 meters, okay? And the question that they'd like to ask is then, how much is the resistance? Same material, just different length, okay? So how you do it is that, since they are directly proportional, we can also write that RA over RB must be equals to LA over LB, okay? So RA is 10, RB is unknown, length is 5, the other one is 2, so we are working on proportions. So RB is simply equals to 20 over 5 equals to 4 ohms. Voila, all right, okay? And you check yourself, conceptually, is it right? Shorter wire, will you get higher or lower resistance? lower. That's why 4 is correct, okay? So another simple example is now we play with the thickness, okay? So if we have the same type of wire, same length, all right, both have a length of L, okay, but different area. So maybe one is 2 mm square and the other one is 1 mm square, all right, okay? So this is 20 ohms and I want to find out what is this, okay, all right? So it's always easier for us to just label it. So this is C and this D, okay? So now RC over RD, and since cross-sectional area is inversely proportional, so I will put AD on top over AC, okay? All right, so RC is 20, RD is what we want to know. AD is actually 1, AC is 2, okay? So RD is equals to 40 ohms, all right? Okay, does it make sense? Yes. Tighter wire, remember our soldier guy? Tighter hole, halfway, stuck, all right? Higher resistance, okay? All right, I hope you get it so far. So just last type of question, which is like combination problems. So you have 2 wires, all right? The other one is tighter and shorter, all right? So let's say if this is 8 meters, all right, and this one I give it 2 mm square, this is 1 mm square, but it's a 4 meter wire, okay, all right? So this is 30 ohms, all right? Find out what is the resistance for this, okay, all right? So let's name it EF, okay? So RE over RF. Okay, so now we have combination. So it will be equals to length is on top. Okay, EF, so it's directly same. Okay, area we flipped. All right, okay. So this is the main formula. So RE is 30 over RF is equals to length E is 8 over AF is 1. Okay, all right. Length L is 4 over area is 2. Okay, all right. So what we get is 8 RF is equals to 8 multiplied by 30. All right. So RF is equals to 30. All right. Ends up being the same. Okay, right. Shorter will reduce the resistance, but being tighter will actually increase the resistance. Okay, all right. So these are the general type of questions that they might ask you. Actually, with this information, you can also calculate what is the value of rho, all right? All you need to do is to plug in the figures for resistance, length, and area. You will get the value of the resistivity for this material. But there must be one thing you need to do. You need to convert millimeter square to meter square first, before you can get the resistivity, all right? How much is it? Find out and let me know. See you in the next video.